In this video, I will show you how you can set up CNC production in TaniqWind Pro. During the video, I will be demonstrating the full process of setting up the CNC production of the shown pressure vessel design. This pressure vessel design has 3 layers with helical paths in the first and third layers and hoop paths in the second layer. For the production, we will move into the Production tab, which has Production, Machine Path, Trajectory, Collision, and Machine Files sections. We will start in the Production section at the Machine Selection button, where we can select a machine from the machine library we want to use to produce this product. For this demonstration, I will start by using this 2-axis CNC machine to show the most basic CNC production process. This machine only has a mandrel or spindle axis and a Z or carriage axis. If you want to know more about defining your machines, you can find this information in the CNC machine definition video. If we press the mandrel button, we can set the actual offset of the product in the machine. For this demonstration, I will set the actual offset to be 1250. This sets the product to the 0 position of the coordinate system. By setting the actual offset and pressing enter, we can see the product move in the visualization of the machine. By pressing the OK button, we can set the actual offset to the file. By pressing the Settings button, we can open the Production Settings panel. If you want to know more about setting and using production settings for your production, this is explained into more depth in the Production Settings video. If we press the Check button, we can check the connectivity of the paths in the design. Here we can see if the start Z coordinate and winding angle of a path matches the end Z coordinate and winding angle of the previous path. If the boxes are not ticked, the paths do not have perfect path connectivity. This can be resolved by adding transition paths in the design. Now we can move to the Machine Paths section of the Production tab. In here we can generate the paths a machine would have to make around a stationary mandrel to apply the material in the designed paths. We can start with setting the machine path parameters by pressing the Parameters button. In the Machine Path Parameters panel, we can see 3 sections: a Path Contour section, a Settings section, and a Point Filtering section. In the Path Contour section, the contour of the machine path can be specified. As can be seen, the software has multiple machine path contour options. With the selected 2-axis machine, we can however only select the open contour, which is a line parallel to the Z-axis. In the Settings section, we can specify the winding distance. For a 2-axis CNC machine, the winding distance is however fixed based on the distance between the mandrel axis and the Z or carriage axis. In the Point Filtering section, we can select to use Machine Path Point Filtering. We can set the filtering parameters, which can be set such that less positions are sent to the machine, while a certain accuracy is maintained. With all the settings in the panel set, we can set them by pressing the OK button. Now we can press the Compute button in the Machine Path section of the Production tab to compute the machine paths. In this computation, the software considers the set parameters as well as the number of degrees of freedom the selected machine has. With the machine paths computed, we can see the machine path represented by the blue line in the plot, with the green points being the filtered points. If we select the full path plot option, we can see the designed material path together with the machine path. For the production of more complex geometries or build-up profiles, bridging of the material during winding can be checked in the bridging plots. With the machine path set, we can convert these machine paths into machine trajectories, which are the movements specifically for the specified machine. We can start by opening the trajectory configuration panel, where we can see 7 sections where we can set configuration parameters. For our selected 2-axis CNC machine, we can however only set the axis rotation direction in the winding position section. With the settings set, we can set them by pressing the OK button. Now we can convert the filtered machine path points into trajectory points by pressing the Compute button. In the plot, we can now see the trajectory points where the TCP would move through. If we select the suspended tape plot, we can see the paths the material would make between the mandrel and the TCP during winding of all of the trajectory points. We can see a lot of twist in the material due to the absence of a payout twist axis. This can also be seen in the material twist plot. Setting parameters and computing the machine paths and trajectories can be done either for a layer, a group, or the entire product at a time by selecting the right node in the product tree. In the last computation, I used machine path point filtering. If we go back to the machine path parameters and deselect the Apply Point Filtering tick box, we can recompute the machine path without point filtering. This results in just the blue machine path line without the filtered point as green dots. If we now reopen the trajectory configuration panel, we can see that we can now also set filter accuracy settings. With these parameters, the accuracy of the trajectory filtering can be set. The trajectory can be filtered such that less programmed points are sent to the machine. The removal of these trajectory points keeps the accuracy within the specified limits. These limit filter settings can be set in the filter accuracy section. With these parameters properly filled in, we can set them to the layer by pressing the OK button. Now we can compute the trajectory points by pressing the Trajectory Compute button. With the trajectory points computed, we can again see them visualized in the plot. For the difference between machine path filtering and trajectory filtering, it can be said that the machine path filtering reduces the path resolution by keeping equally spaced points. Trajectory filtering is keeping only the points needed to keep the filtered trajectory as close as possible to the original one within the set accuracy. For this demonstration, I will be using the machine path filtering previously shown. With the trajectory points computed, we can run a collision check by pressing the detection button in the collision section of the production tab. During the collision check, it is checked whether the tool collides with the mandrel and whether all points can be reached by the machine. The check runs for all the layers in the product. If we now move to the simulation panel in the Analysis tab, we can simulate the computed production. In this simulation, we can see in which points the collisions or reachability problems would happen. For collisions, we would see that the tool lights up red, indicating a collision at the specific point. And with this point known, it can be used to resolve this collision by, for example, increasing the winding distance of the layer or by limiting tool orientations. With the configuration computed and the production checked, we can press the Generate Files button in the Machine Files section of the Production tab to generate the machine files. For this file generation, the post-processor in the machine definition is used. This is explained into more depth in the CNC machine definition video and the post-processor video. Now, if you would want to change the machine we are using to manufacture the product, We can simply do this by clicking the Select Machine button in the Production section of the Production tab. And now we can select another machine we want to use for the production. I will select the 5-axis CNC machine to show the production capabilities of a machine with more degrees of freedom. With the new machine selected, the machine paths and trajectories are reset. If we now go to the Machine Path Parameters panel, we can see that all the path contours can now be selected since we have a cross carriage or x-axis defined. The now extra possible contours are an enveloped regular contour which follows the shape of the product, a fixed fiber length contour which keeps the distance between the TCP and the mandrel constant, a continuous tension contour which will avoid slack in the material feed during winding for systems which cannot take back in material, like wet winding systems. The placement contour is for automated fiber placement, and TaniqWind Pro has the option to load in custom path contours by some file types like DXF. For now, I will be using a continuous tension path contour with a winding distance of 200 mm, and I will use machine path point filtering with the shown settings. With the settings set, we can press the OK button to set the parameters to the layer and press the Compute button to compute the machine path. If we now move to the Trajectory Configuration panel, we have some more settings to set. In the plot area, we can see a visualization of the specified winding position. For now, I will wind at an angle of 0 degrees with a positive axis rotation direction, and we will wind non-tangent to the surface. In the winding position section, we can set the position of our tool relative to the product. In the tool orientation section, we can set the allowed orientations of the tool itself. In here, we can either completely disable a tool orientation or we can limit certain tool orientations. On this machine, we have a payout twist axis, which for now I will set to 180 degrees. We can again set the settings to the layer selection by pressing the OK button and compute the trajectories by pressing the Compute button. Now we could again run a collision detection, check the simulation, and generate the production files. This is the end of the TaniqWind Pro CNC production demonstration video, where I've demonstrated how you can set up your CNC production in TaniqWind Pro. If you're interested in other highlighted feature videos, these can be found at the Taniq YouTube channel.